Okay, so when we're looking at parallel, we'll just start with parallel to begin with. Parallel means that they actually kind of line up together. So I like to call them train tracks. So they have the same slope. That means that their gradients, remember the gradient is a determination of slope, must be the same. Now I'm going to write this statement at the top. Y is equal to mx plus c. So when we're focusing on the gradient, we're looking for this number here. That's our m. That m refers to our gradient. Now, if they are the same, they are parallel. All right, so we're going to look at the first question to determine if they are parallel. So we've got negative a half and 2. So clearly we can see that they are not parallel. So I'm just going to write down the 3. So it's either going to be parallel, is it going to be perpendicular, or is it going to be neither? All right, and I'm going to do that for every single one of them, so we can kind of, just to see if I'm going to kind of cancel out as we're going along. Perpendicular and neither. And for the last one, I'll throw it a little bit higher, parallel, perpendicular, or neither. So I'm just going to cancel them out to determine which ones they are. All right, so the first one, we know that it is definitely not parallel. All right, let's have a look at the next one. All right, the number in front of this one here, it doesn't look like it's got a number, but we can see just by looking at it, how many x's do we have? We have 1x. And this one over here, we have negative 1x. So this number and this number, once again, are not the same. So we're going to cancel parallel out. Now the next one's a little bit interesting because unfortunately, we don't have y is equal to mx plus c. We have 2y. So what I'm going to do is I'm going to get rid of this 2 here by dividing everything by 2. All right, let's see what that looks like. That's going to give me y. And divide 4x by 2, well, that gives me 2x. And that gives me minus 7. Now we're going to look at that number at the front. We've got a 2. Well, we've got a 2. Okay, as soon as we reach the one that we've got, so that means that this line is parallel, therefore it can't be perpendicular and it can't be neither. So the last one is parallel. All right, let's have a look at the next one. So the next option it can possibly be is it can be perpendicular. Now perpendicular just means that they cross at a right angle. Now, another way of looking at it is if there are two gradients, m1 times m2. Now I'm just using 1 and 2 just to show that they're two different gradients. If you multiply them together, you get negative 1. The other way to think about it is if they have the complete opposite gradient. So a bit of an example there is if I have a gradient of 2/3, I might write that in a different color. If we have a gradient, let's say, of 2/3, the complete opposite to that, if we multiply, is 3 on 2. So notice I've switched these two around. And I've also got to change the polarity, which is actually the negative polarity. So one's got to be a negative and one's got to be a positive. All right, let's see if we can have a look at this first one again. So we've got negative 1/2 and 2. Now what I'm going to do is I'm going to write 2 as 2 over 1. So they both look like fractions. Now, having a look, is this number here flipped? It looks like it is. And one's a negative, one's a positive. So that means that this one has got to be perpendicular. So we're going to cross out neither. Okay, so the first one is perpendicular. All right, next one, we've got 1 versus negative 1. Now I'm actually going to go back to, and have a look at the top right-hand corner of the screen. I'm going to go back to m1 times m2 is equal to negative 1. So I'm going to get number 1. I'm going to times it by negative 1. Does that equal negative 1? In this case, it absolutely does. So this means we have two lines that are perpendicular, which means neither's out as well. All right, so the first one is perpendicular, second one is also perpendicular, and the last one is parallel.